In this section, we're trying to prove and disapprove. Most of the time, we're trying to prove it. If it doesn't work out, then we can say disapprove. Here's one example. We have 1 over 1 plus cosine x minus 1 minus cosine negative x. Try to prove that equals to the right-hand side. Now, first, we see a negative. The first thought is this is going to be an odd even function. We're going to use that to simplify it. So we have a 1 plus cosine x minus 1 over minus cosine x. Now, let's try to find the common denominator so we can put two fractions into one. So the common denominator, luckily, on the top is 1. So that makes the calculation very easy. On the other side is multiply 1 plus cosine x, right? Now, they have the common denominator. Now, we can merge the terms. When you merge it, be careful. Put the parentheses for the second numerator. So, when you remove the parentheses, you remember that, okay, the sign needs to be changed. Okay, for the denominator, this is what? Is the perfect square, not the perfect square, the differences of square, which is a plus b times a minus b equals to a squared minus b squared. So that means I have 1 square minus cosine square. Okay, simplify the numerator. I have a negative 2 cosine x. In the bottom, when you see 1, the first thing I think about is sine square plus cosine square equals 1. Now, simplify it. Then I have a negative 2 cosine x over sine x. Well, that still looks a little bit off from the right-hand side. Well, maybe because you're not familiar with the right-hand side. If I can write the right-hand side into cosine, maybe with sine and cosine, everything looks easier. So this should be cosine over sine. And cosecant is 1 over sine x. Look at how does these two related. Well, I can write this x, this guy, times this guy, right? Because I can break the fraction into two fractions in terms of multiplication. Then we're done. The left-hand side equals to right-hand side. We finished the proof. Because this is equals to cotangent and cosecant. Second example, try to pause and do it by yourself and come back and check the answer. See what you got. Okay, the left-hand side is secant plus tangent over cotangent at cosine. First, always convert this into sine cosine. Cotangent is cosine. Okay, one way to do it is multiply the common denominator, which is cosine, sine over cosine times sine. So on the top, you will end up to get sine plus sine square. In the bottom, you will have cosine square plus cosine square times sine. Okay, so the next thing is maybe my first attempt is I will think about maybe pull out, factor them, see if I can simplify it. Is equal to sine theta times 1 plus sine. And the second one is cosine square over 1 plus sine theta. Okay, nice. These two, they can cross cancel. And now I have sine theta over cosine theta. Now, what we're trying to get, the right-hand side is secant square. Is secant square, which is 1 over cosine square. Well, it seems like the left-hand side doesn't really equal to the right-hand side. Did I do something wrong, or they're really not equal? One way to prove it is to use GeoGebra. Look, that's the left-hand side. Now, let's type in the right-hand side, which is the secant square. Oops, I shouldn't do that. Look, these two are not equal. They're not overlap. The blue line and the black one is complete different. So we just use decimal to disprove that these two are not equal. Then we're done. Okay, let's do the last one. So the last example that I got is secant negative x minus tangent square over tangent x times 2 plus tangent x over 2 plus cotangent x minus 2 times sine square equals to cosine 2x. Okay, so we need to use one of the identity that we haven't learned yet. So here's the hint. Let me use the black one, which is 1 minus 2 times sine square x equals to cosine 2x. So what does that mean? That means if we can prove this messy stuff equals to 1, then we're done. Because here's one property or identity tells us that, okay, this is going to be equal. Okay, so I'm going to use the same idea. The first one, I'm going to use the blue pen. The second one, I'm going to use the black pen. So you can see these two, how I work with these two one by one. So for the blue part, I have a secant square. If you see the square, the first thing is you think about odd and even. Secant is 1 over cosine. Cosine is even, so that means secant is going to be even. So I have a secant square minus tangent square over tangent square. And if you see square, you need to think about the Pythagorean way identity. Secant is equals to 1 plus tangent square. Nice. These two just got cancelled. Then we have 1 over tangent x. We're done. I think that's the simplest thing that you can get. Or this can be cotangent. Depends on later which one seems more easier for us. Is either 1 over tangent x or cotangent. Now, the second part. With a 2 times. I copied this wrong. So if it doesn't work out, it's my fault. So this should be 2 and 2. I'm missing 2 here. Okay, so the first step is I need to factor the 2 out. I have a 2 times 1 plus tangent x over 2 times 1 plus cotangent x. These two got cancelled. Tangent x, cotangent x, we write that as sine and cosine. So I have a 1 plus sine x over cosine x over 1 plus cosine x over sine x. You can either choose to find the common denominator or times the common denominator. Let's just do the common denominator things. One, I can rewrite it as cosine over cosine, or sine over sine. Now, simplify it. I got cosine x over sine x, plus. And then I have a cosine x over sine x times cosine x over sine x. And then we flip them. These two got cancelled, and then we end up to have sine x over cosine x. What's that? That's tangent x. And we want what? We got 1 over tangent x, and then here's tangent x. When these two terms, remember, these two are multiplication. I do this separately so that I know that it's easier for me to follow. So these two multiply together. 1 over tangent x multiply tangent x. Give me a 1. Then we're done. We just proved that. Again, you can use GeoGebra to check the answer. See if these matrices are equal. The left-hand side equals to the right-hand side. Okay, that's it for today's video. Let me know if you have other questions.